Okay, number 21. Wait, let me just pull this down a little bit. Okay. In number 21, we want to find vertical asymptotes of this function. All right, well, this function is a rational function, and vertical asymptotes occur at the denominator of a reduced rational function. It has to be reduced. So if we have a reduced rational function, in other words, we can't cross off a zero from the numerator and denominator. So if we have a reduced rational function, then vertical asymptotes occur at the zeros of the denominator. So all we have to do is factor this denominator. All right, let's see. Let's do that. First we'll factor out an x. Okay, and then we'll try to factor x squared plus x plus 10, and we'll quickly see that we can't factor this. All right, and so then we say, okay, maybe we can use the quadratic formula. All right, so we'll calculate the discriminant. Okay, that's the discriminant, to see if it can be factored. The discriminant is b squared minus 4ac. All right, and b squared is 1, a is 1, and c is 10. That's 1 minus 40, minus 39. It's negative. Negative discriminant. Okay, that means no zeros, no real zeros. Okay, so the only zero comes from x, and that means x equals 0 is the only vertical asymptote. So we have vertical asymptote at x equals 0, and that's the only one. In number 22, we want to find the slope of the secant line from x equals 2 to x equals 3 through the curve determined by f of x equals x squared minus 2x plus 5. All right, so let's remember the formula for the slope of secant line. From, let's say, x equal a to x equal b. So the slope would be f of b minus f of a over b minus a. And this is really the regular slope formula, y2 minus y1 over x2 minus x1. But here, for the x values, we use a and b. And for the y values, we use function notation, f of b, f of a, for the corresponding y values. All right, so this is just the regular slope formula. And in our case, we have a is equal to 2 and b is equal to 3. So we have f of 3 minus f of 2 over 3 minus 2. So let's figure out f of 3 and f of 2. Maybe we'll do this on the side. Let's do f of 3. Okay, we're substituting into this function. 3 squared, that's 9. 2 times 3 is 6, plus 5. So we have 3 plus 5 are 8. And now let's look at f of 2. That's 2 squared, that's 4. Minus 2 times 2, minus 4, plus 5, so that's 5. All right, now substituting into here, f of 3, that's 8. minus f of 2 is 5, divided by 3 minus 2, which is 1. And we get 3 minus 2 is 1. So we have 3 over 1, or 3. 3 is the slope of the secant line. In number 23, we want to write an expression for the slope of the secant line. Here's our secant line, this gray line over here in this picture. All right, so here are our x values, c and x. This point, just a second. Okay, this point has coordinate. This point has coordinate x, and the corresponding y value we're using function notation is f of x. And here this point has coordinate c, and the corresponding y value using function notation is f of c. So the slope will just do the difference of the y values, that's f of x, minus f of c. These are the two y values. And then the difference of the x values in the denominator, that's x minus c. And now let's look at the other picture that we have here. Okay. And here we're calling the first point x and the second point x plus h. This h is the distance between these points. That's h. Okay. All right, so what's this point? Well, this point is x plus h, f of x plus h. And this point is x comma f of x. So let's write down the formula for the slope. So we have first the y values, take the difference, and we have f of x plus h minus f of x. And now in the denominator, the x values, just take the difference, and we have x plus h minus x. Okay, this simplifies, because here in the denominator we just have h, so it's f of x plus h minus f of x over h. In number 24, we just want to write down the limit definition of the derivative. So if we have a function f of x, the derivative, we'll use the notation f prime of x, or we could use the notation, we read this, the derivative of f of x with respect to x. With respect to x. And this, we could also read this the same way, the derivative of f of x with respect to x, but sometimes we just say f prime of x. It means the same thing. This little straight line over here we call prime. So f prime is a short way of writing the derivative. Okay, but what we want is the limit definition. Here's the limit definition. F prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x over h. And that's the limit definition. If we look at the previous picture, the graph that we looked at before, let's look at that again. Right here, we see this expression, f of x plus h minus f of x over h is the slope of the secant line, and h is the distance between x and x plus h. So if this distance gets smaller, all right, then the secant line gets closer to the tangent line at x. And that's what the derivative represents. The derivative, as h goes to 0, the slope, the secant line becomes this tangent line. Okay, let me just draw the tangent line. And the derivative is the slope of this tangent line. All right, so we keep on taking secant lines closer and closer. Let's say, let me just draw in here. Here's this dotted line, let's say, is a secant line. That's getting closer to this tangent line. So the slope as h gets smaller, the slope of the secant line gets closer to the slope of the tangent line.